Okay, when I first saw this problem, my gut reaction to it was going to be a denesting problem, all right? And the reason for that, I'm looking at denesting as not being terribly difficult, but then I notice they're cubes, cube roots, I mean. So what I want to do is go to the whiteboard and talk about my attempt to do the problem initially anyway. And I just want to go through what I did, all right, initially, but I stopped doing it at some point. Now, if you have the square root of 2 plus root 5, and you were to denest it, it's a fairly easy denesting. You would just simply say, oh, I think it's the root of A plus the root of B. Then you'd square both sides, and what would you get? You get 2 plus root 5. Then you get A plus B plus, what do you get there? Well, let's take a look at it. You'd get 2 root AB. And then you equate coefficients. What would I equate over here? A plus B is equal to 2. And then I would equate 2 root AB would be equal to root 5. Yeah, you could solve this thing for A or B if you wanted to. Now, granted, these might be nasty numbers. It's incidental, but you could denest it. And I'm going to square this one over here. What do you get? You get 4AB equals 25. And over here, if you write this down, you're going to get A equals 2 minus B. Now, I'm not going to continue with this, but I'll point out, you could easily plug this in now. And what do you get? You get 4, 2 minus B times B equals 25. All right? So let me just review what I did over here. If I had a square root, I'd write this down. I'd square both sides. I'd get this over here. Next thing is I equate coefficients. You know, A plus B is 2, and that's the whole number part. And then this thing over here is the radical part. Write this down. I solve the first equation, A plus B for A. I would get 2 minus B. The second equation, I square both sides. I get 4AB equals, I'm sorry, I made a mistake already. I'm glad I looked back over it, by the way. I get a 5 there, a 5 there. I'm squaring both sides. And then you solve the equation. And what do you get? You get, let's see, 8, right? Because you get 4 times B times 2. That's going to be 8B minus 4B squared equals 5. Then you get 0. You get 4B squared. And again, this might be a nasty looking number to you. I don't know. 4B squared minus 8B plus 5. Let's see if I did that right. 4 times 2 is 8, 8B, and then 4 times minus 4B squared. I did that. And yeah, let's put this down. What's B going to be equal to? Well, 8 plus or minus, that kind of nasty number, isn't it? Let's see, 64 minus, let's see, 4 times 4 is 16 times 5 is 60. All right, let's keep going. And what's B going to be equal to? 8 plus or minus, well, 64 minus 60 is 4. The square root of 4 is pretty easy to do, by the way, over 8. Let's keep going. B equals, let's see, you get 8 plus or minus 2 over 8. I get two numbers here. The numbers I'm going to get over here is going to be 10/8. And the other number I'm going to get over here is going to be 8, let's see, 8 minus 2 is 6/8. I'm going to reduce those. This is going to be 5/4, and this over here is going to be 3/4. All right? Now, if you know B, you would know A. I want to point out what I mean by that. If I tell you B is 5/4, what are you going to get for A? 3/4. And this is kind of interesting, by the way. If I told you B was 3/4, what's the A going to be? 5/4. So I denested this root, by the way. And what's it going to be? It's going to be the root of 3/4 plus the root of 5/4. All right? And if you look at that, it doesn't look too bad. It's actually root 3 plus root 5 over 2. All right? Now, again, if that was a square root, but the problem with this problem over here, it wasn't a square root. But I still thought to myself, you know, maybe it's easy to denest that. All right? By the way, you may not agree with that was easy, but it didn't look too bad. But that's not helping me with the problem. So then the question is, you know, what are you going to do about it? I guess one thing you could do about it is just look at the cube root and pretend you could denest it. And this is where I got into trouble, by the way. So I wrote down the cube root of 2 plus root 5. And, you know, the bottom line is you're going to have to cube both sides. And I realize if I cube both sides, I'm going to have to equate things, and there's going to be a root in the problem. And what I did was I made some assumption, and the assumption I was going to make that this worked out like A, some whole number, or maybe shouldn't say whole number, some nice looking number, B, and root 5, all right? And then I cubed both sides, all right? And so while you cube both sides, I'm still trying to equate coefficients. And this is where I got into trouble, by the way. All right, now if you do that, what do you get? You get 2 plus root 5. And over here, you can get A cubed. Let's see, plus 3 A squared. I'm using the binomial theorem. And then it's going to be B root 5. Then you're going to get plus 3A, B squared. And then when you square the root 5, you get 5. Then what do you get? Plus. Then you're going to cube that thing over there. So it's going to be B cubed. And cubing the root 5 is going to be 5 root 5. All right, what does this give you? A cubed plus 3 root 5, A squared B, plus 15 AB squared plus 5 root 5 B cubed. All right? And then what I did was I wanted to equate the coefficients, hoping it was going to be something really simple to do. And I'm looking for these things that would match the 2. I'll put this down for you. And the things that would match the root 5. And I'll put those over here for you. Oops, sorry about that. Made a little mistake there. It's a dead end anyway. In my opinion, it's a dead end. And I kind of wasted precious time doing that, but let's maybe factor this a little bit. This is A. You get A squared plus 15B squared. That's not so bad. Over here, I'm going to factor a B out and a root 5. I'll put that in the end. And what would you get there? You'd get 3, let's see, that would be 3A squared. Let's see if I did that right. Yeah, 3. Got the root 5. I got the B. Yeah, good. Then what do you get next? Plus 5B squared. And then this is where I said I'm going to have to, give up on this one because this doesn't look like an easy thing to do, by the way. That would be equal to 2, and this would be equal to 1. All right? So I gave up on that, and I said to myself, that looks like it's really kind of like maybe going in the wrong direction at that point. So then what I did was I thought about it, and I looked at the problem again, and I made an assumption about its answer. And I'll put on what I mean by that. So if you took the cube root of 2 plus root 5 plus the cube root of 2 minus root 5, I made some assumption that's going to produce a number. I just don't know what the number is, and I called it x. Then to make the problem a little bit easier for me, I made a substitution. I'll tell you what the substitution I made. I said u was going to be equal to the cube root of 2 plus root 5. And I said v is going to be the cube root of 2 minus root 5. All right? Then when I would write down u plus v equals x. Then what did I do? I cubed both sides. Now, someone's why do you want to do that? Because u cubed is simple. And so is v cubed. So I'm still cubing both sides. All right? And what do you get over here? Well, I'm going to cube u plus v, and I'm going to cube the x. All right? All right. What do you get? You're going to get u cubed plus 3u squared v plus 3. I'm using the binomial theorem, by the way. uv squared plus v cubed is equal to x cubed. All right? Now, I know what u cubed is. I know what v cubed is. All right, I'm seeing that up here, by the way. So I'm going to write that down. It's going to be 2 plus root 5. And this guy in the end is going to be 2 minus root 5. This is still equal to x cubed, by the way. By the way, I see something immediately nice about that. But I'm looking at this guy over here. I'm wondering, what am I going to do about that? Well, I'm going to factor it. And what would you get? You get 3, let's see, a u and a v. And what do you get there? Let's be careful about that. You're going to get u plus v. All right? Now, wow, what do you do now? Well, I think u plus v is equal to x. All right? And I'm looking at these two over here. I'm going to keep moving through that. Well, let me write that down now. So you get 2 plus 2 is 4. The root 5's cancel. And you're left off with 3uv. And u plus v is just equal to x. All right, I got that right there, by the way. And then over here, you get x cubed. I still got a trouble over here. I still have that uv in it. So what I want to do is I want to write down u times v. I need to know what that is, by the way. So I write it down. I get cube root of 2 plus root 5, cube root of 2 minus root 5. And uv is going to be the cube root. I can multiply the arguments together. And they're real numbers, by the way. It's pretty easy to do that. You can get 4 minus 5. They're conjugates, by the way. And you're going to get the cube root of minus 1, which is minus 1. So now I got something in x at least. So I get 4 minus 3, because uv is minus 1, x equals x cubed. This is a more recognizable expression to me now. All right? So what I'm going to do over here, I'm going to rewrite it as x cubed plus 3x minus 4 equals 0. I certainly would like to know what x is, by the way. And I'll tell you why. X is the answer to the question. And how do I do that? I'm going to use the rational root theorem. And the possible roots over here, plus or minus 1, 2, and 4. Well, looking at it, I immediately notice that 1 is a root. How do I know that? 1 plus 3 minus 4 equals 0. So I know that this thing is going to be x minus 1. And then I got this quadratic over here. And that's going to be x squared. And this will be plus 4 here. I don't know what's in here, by the way, in that middle. So I'm going to go through a long division to do it. And long division should be fairly easy to do. So x minus 1 divides into x cubed plus 3x minus 4. I would say x squared because you get x cubed. Then you get minus x squared. I'm going to subtract. You get x squared plus 3x minus 4. I'd say plus x. What do you get there? X squared minus x. You subtract. You get 4x minus 4. And that would give you plus 4 because that would give you 4x minus 4. And as expected, a remainder of 0. So I know this is plus x now. All right? So I know there's one root. It's 1. And I'm wondering what's the root of the quadratic. Let's write this over here. What's the root of that? Maybe it's interesting. And what do you get there? X equals. Let's take a look. You get 2, let's see, minus 1 plus or minus. Let's see, 1 minus 16. All right, this is trouble now. And why is that? It's not a real number. This is complex. And I want to go back to the original problem, by the way. And looking at it, I'm going to point out that's a real number, that's a real number, that's a real number. All right? So I only got one answer over here. What answer do I get? I got x equals 1. What's my conclusion? My conclusion is that this sum is equal to 1. End of story. Thank you.